Hi, and welcome to this part 2 of our video that's all about the dividing head. We finished up our last video by looking at how to align the head on the machine using a 4-jaw chuck and a test bar. Now, we want to look at how to use this, and I mentioned in the last video that there was two ways. There was the direct indexing with the direct indexing plate and the simple indexing with the simple indexing plate. But I lied. There is a third way, and it also uses the simple indexing plate, and that, well, is angular indexing. So let's start with the easiest method, which is direct indexing. With direct indexing, we use the direct indexing plate, and in this case, this plate has 24 divisions on it. And we use this with the worm gear disengaged just by pulling the plunger back, turning it to the division that I want, inserting it, cutting, and so on and so forth. It's really not more complicated than that, but there is one little thing that you have to watch out for, and that is the number of divisions that you want. Now I have 24 divisions on this plate, so that means if I want 2 divisions, I have to move 12 and 12. So 12 for the first division and 24 for the second. Not really, because I cut the first, move to 12, cut the second, and if I want to come back to my start point that I've already cut, well, I just come back to the first slot that I was in. But there is a problem. It's not the slots that I'm counting, it's the spaces. So you'll notice here that I'm on the slot number 24, and that's where I want to start if possible, because it makes things easy. So let's say I'm on 24 and I want 12 divisions. Well, I start on 24, pull out, and then I go 1. So number 1 here isn't the first slot as much as it is the first space. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 spaces, engage. Oh, I'm on the number 12. And let's say I wanted to come back to my start point. Well, I should be 12 away. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And sure enough, I come back to the slot number 24. So direct indexing really is that easy. I have 24 slots on my dividing head here. Could be different with yours for the direct indexing plate. And that means that I can count with me, I can do 2 divisions. Why? Well, 24 can be divided by 2. I can do 3 divisions. Why? Because 24 can be divided by 3. I can do 4 divisions. I can do 6 divisions. I can do 8 divisions. I can't do 9, 10, 11, but I could do 12 divisions. And finally, the only one left would be 24. So it's limited as far as what I can do, but it is really, really easy to do and almost impossible to get confused while you're doing it. And that's important, and that is direct indexing. The only thing you really have to remember here is you're counting spaces and not slots. So that's why I started here in groove 24. Now if you start in your last groove before the groove number 1, well, that means that all your numbers will coincide. So by starting at 24 and I wanted to do 2 divisions, well, I went 12 and 24. And I started in slot number 1. Well, for 24 I would have had to go to 13 and 1. A little more confusing. So really start in 24 whenever possible. And well, if I'd wanted to do, let's say another example, I wanted to do 3 divisions. Well, 24 can be divided by 3, and it gives 8 times 3 is 24. So I would start in 24, I would go to 8 mil, 16 mil, 24 mil. if I didn't mill right at the start. If I wanted 4, well, 6 times 4 is 24, so I would have started in groove 24. I would go to 6 mill, 12 mill, 18 mill, and 24. I'm back to my start point. I can mill if I hadn't already milled it. You see, it's that easy. Direct indexing. Now, with simple indexing, I'm going to be using the hand wheel here to turn the part. What's the ratio? It's not 1 to 1 because we can see that we're not turning almost not even close as fast here as I am turning here. Actually, the ratio is 40 to 1. Here's a worm gear that comes from a head like this one, and well, you'll have to take my word for it, there's 40 teeth on it. The worm, well, is a single start worm. And, well, a single start worm means that when you do one revolution, your worm gear will advance 1 tooth. 40 teeth, 1 turn of the worm. 40 to 1. And that's the ratio. So I have to do 40 turns of the hand wheel here to get 1 full revolution on the part. And that is crucial here to know where we're going with simple indexing. And that's why we have these indexing plates here, because it gets confusing very fast. Now, if we look at a basic example, let's say I want 20 divisions on my part. That's pretty easy to figure out. If 40 turns of this equals 1 turn of that, what will I have to do if I want 1/20th of a turn? Well, it'll be 40, the number of turns for 1 full revolution, divided by 20, which is the number of divisions that I want. 40 divided by 20 equals 2. And that means that each time I do 2 full revolutions, I'll be cutting 1 surface. 2 full revolutions, cutting another surface. And by the time I've gone through that movement 20 times, I will have come back to my start point, and I'll have 20 divisions. Very straightforward, 20. Why is it straightforward? Well, because it gives a whole number, 2 full turns. So all I have to do here really is set my plunger in a hole that I recognize, and then pull it out, 1, 2 full turns, come back to that hole without ever backing up. I always want to go clockwise, and that way you don't get lost. Cut, and so on and so forth. Very simple indexing, but simple can get complicated. Another example, let's say I wanted 10 divisions. Well, our formula we figured out already at the start was 40 over the number of divisions. That's what we did with 40 over 20. So if I want 10, 40 over 10, 4 turns. Every 4 turns gives me 1 division. And that'll give me eventually, if I work my way around, 10 divisions. That's fine and dandy, and we can see that. But what if it doesn't divide? 40 divided by, well, let's take 6 divisions. Now, I can hear it already. I can do 6 with my direct indexing, and that's how you'd do it if you could. But this is just an example, and I don't want to have to turn for 2 days here. I want something that's going to be pretty quick to get around with. So let's say 6 divisions. My formula here is 40 over n. So let's head over to the whiteboard and take a look how that works out. So we know that we want 6 divisions, and we also know that our formula is going to be 40 over n. 40 is the number of turns for 1 turn, and n is the number of divisions that I want. It is crucial here to remember one thing. Don't calculate this in decimals on your calculator. It is very difficult to succeed if you go down that route. It is very simple to succeed if you remain in fractions. So I have 40 over n, that's 40 over 6, and that gives, if I simplify that, 6 4/6. Now I could say 6 2/3 as well. That would be even simpler. But I know I'm going to have to go up. That doesn't mean anything to you right now, but you'll see in a second. What does this mean, 6 4/6? It means that to get one division, I have to do 6 full turns of my crank plus 4 spaces on a 6-hole whole circle. So if I have on my indexing plate a circle that it has 6 holes, that's what I do. However, this is problematic. I don't have 6-hole circle on my plate. It's too small. And I knew that 3 I wouldn't have either. That's why I didn't go there. So what can I do? Well, if I multiply the bottom by something, I have to multiply the top, but the fraction will still remain the same. So 4/6 equals what? 12s? 2 times 6, 2 times 8 is 8. 8/12. I don't have a 12-hole whole circle on my indexing plate. So there, that's just another problem. But I do have an 18. So 6 times 3 is 18. So 4 times 3 is 12. And that means that I can change 6 4/6 into 6 12/18. It's the same value. And that's why my final answer here, what I'm going to be doing over there, is 6 full turns of the crank, and then I'm going to advance 12 spaces on an 18-hole circle. It's just that simple. If you want another example of this, don't hesitate to go take a look at the gear cutting video that I put out a few years ago. It has an example, I think, for a 14-tooth gear, something like that. So let's get back to our machine. Now, I know I don't have a whole circle of 18 holes on this side of the indexing plate. So I'm going to flip it over to get access to a whole circle of 18 holes. So for 6 divisions, I want 6 full turns and 12/18ths of a turn for each division. So I position my plunger in a hole that I can recognize. So I always use that central row, the row that has all the whole circles numbered on them, and I've adjusted it to line up with the 18-hole circle. Now, these are sector arms. They're very important if you don't want to get lost, because 6 full turns and 12/18ths of a turn is never going to fall in the same place until I get to the very end and come back to my start point. And it's very, very easy to get confused and get lost. And well, whatever you're cutting won't be good. So to avoid that, we use sector arms. And here's how we use them. We'll lean them up on the engaged pin in the clockwise movement. I'm going to turn my hand wheel clockwise, and I'm always going to bring my sector arms up to the pin in a clockwise direction. So I lean it up there, and I'm going to open up wide, because now I want to count out 12 spaces. You gotta watch out. Some people will say 12 holes. But it isn't 12 holes. It's 12 holes not counting the hole that you're engaged in. A better way of saying it would be 12 spaces from where you are. So let's count them off. I'm going to pull out here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I never said this was going to be exciting. So I hold this sector arm in place, and I come and lean the other one onto the pin that I just positioned in the 12th hole, not counting the hole that I was in. So I have a spacing between there and there of 12 spaces. Important. This is where I'm going to lock the sector arms. I'm just going to lock them in place there. Now, when I lock them, I don't lock their movement one with the other. I just lock them so that the spacing between the two doesn't change. So let's start over. Just to figure out, I'm going to come here, move my sector arms away. I'm going to come in a clockwise fashion and engage in that first hole. Now, if you don't have a numbered hole that you can engage in, you can always mark the little hole with a Sharpie, a permanent ink marker or something of the sort. So I'm there. Lean up in a clockwise motion. I'm leaned up. I cut my first division, making sure that I'm locked there. Now there's no backlash because I came up to the hole, turning the handle clockwise. So I'm going to unlock. I've done my first hole. I've done my first surface, and I'm going to go 1, 2, 3, 4, 5, and 6. That's my 6 full turns, plus 12 18ths of a turn. I'm leaned up here. Right now, before I lock, before I do anything, I move my sector arms to lean up against the new pin position in a clockwise fashion. I lock, I mill my second surface, unlock, pull my plunger. 1, 2, 3, 4, 5, 6, and 12 18ths of a turn before I do anything. Bring this up, lock, mill my third surface. Then I pull out. 1, 2, 3, 4, 5, 6, and I'm back at my start point. I've milled my 6 surfaces and I'm back on my original hole. I'm ready to start a second part. Now, you know that I'm a lazy machinist. That doesn't mean that I don't like to work. That means that I don't like to work in an inefficient way. And, well, I didn't choose the 18-hole circle for our last example of simple indexing for nothing. It's because that's the whole circle that I needed for the angular indexing problem. So everything works out and I don't have to readjust things here, which is great because I'm lazy. Angular indexing is all about 9 degrees. What does that mean? Well, I know that 1 full turn of my hand wheel here equals how many degrees? 40 to 1 turn. 360 is 1 turn, and divided by 40 means 9. 1 full turn of this hand wheel equals 9 degrees of movement on the head. Now let's say I want to move by 20 degrees between 2 surfaces. So I have 2 surfaces, and let's say I want to move 20 degrees. So in reality, 180 plus 20, which would be 200 degrees. But it'll just be 20 on the part's movement. If I wanted to do that, well, I'll turn 1 full turn, 2 full turns like we saw before. That gives me 18 degrees plus 4 spaces on my 18-hole circle. Simple. I come up to my first hole, the loose or the play backlash is taken out. I lock, mill my first surface. Unlock, get the plunger out, go 1 full turn, 2 full turns, and 1, 2, 3, 4 spaces. Lock in place, mill my second surface. I'll have my 2 surfaces spaced by 20 degrees. Now, if I wanted 20.5 degrees, well, I would have gone 1 hole further down, because each hole is 1/2 degree. If I just want to do 2 surfaces, I don't need sector arms. But if I want to do several surfaces on the same part, well, I might want to set my sector arms for the correct spacing to get the number of degrees or 1/2 degrees that I want without having to count every time. So that's the same as simple indexing for that. So interesting here is you can get more accurate with the whole circle that you choose. Now I'm using an 18 hole circle here, which is a multiple of 9. They have to be a multiple of 9. But had I used the 27, I could have done 1/3 of a degree. Had I used the 36, well, that would have been 1/4 of a degree. And if I used the 72, which I don't have, well, that would have been 1/8 of a degree. So you can see it can get quite accurate here.
It is also important to note that it is very difficult to align the headstock to the footstock, keeping both in line with the axis of movement of the table. And that's why, whenever possible, it's nice to have them keyed.
And well, that pretty well brings us to the end of this video. It's what I wanted to look at as an introduction to the dividing head. So, until we meet again, have fun, be safe, and happy machining.